Okay, so earlier this week you learned about the law of sines. Today we're going to discuss the law of cosines. Yeah? So first thing I'm going to do is draw a reference picture. The law of sines, just like the law of cosines, is for triangles that are not right triangles. If it's a right triangle, we use Pythagorean theorem SOHCAHTOA. Yeah? But if it is not a right triangle, those two things don't apply. Why do I all of a sudden have like a weird, I can't draw this thing? Oh, because I was going in the wrong direction, that's why. Okay. So that's our reference triangle. I'll zoom in a little bit. So reference triangle. You will notice the side lengths are labeled with English letters, A, B, and C. The angles that are across from those sides are labeled with the corresponding letters in the Greek alphabet. A goes with angle alpha, the first letter in the alphabet. B goes with angle beta, the second letter in the Greek alphabet. C goes with gamma, the third letter in the Greek alphabet. So for those of you who have not seen Greek letters before, the fishy is called alpha. That one goes with side length A. The curly B is beta. That goes with side B. And the upside down dead fish hanging from a fish hook is gamma. Yes.
I can't hear you because
I have my great stink of bonking if you continue to be a problem. Yeah. English letters for side lengths, Greek letters for angles, corresponding letters with their corresponding angles. Yeah. This was important for the law of sines because when we were making mistakes with the law of sines on Monday, a lot of it, or not Monday, I didn't see you Monday, Tuesday, a lot of it was mismatching sides and angles. We always want to pair the angle with the side across from it because the angle determines the side length across from it. Skinny angles produce short opposite sides. Wide angles produce long opposite sides. Yeah. So what I'm going to do is I'm going to give you the new formula, and then we're going to compare. Why do I need a new formula? I already know the law of sines. Yeah? Okay. So law of cosines says that if I want to know a side length squared, I'm going to take b squared plus c squared minus 2 times b times c times cosine of alpha, which goes with side length a. That's our new formula, yeah? Next to that, I'm going to write down our old formula, the one from Tuesday, our law of sines. Why is that so messy? Law of sines was a whole bunch of fractions. Sine alpha over side length A sine beta over side length B equals sine gamma over side length C. The ratio of the angle to its opposite side should be the same for every side length in the triangle. Yeah. The question is, why do I need two separate formulas? So we're going to consider a question. And that question is, I want to find a missing side length. If I want to find a missing side length, what do I need in order to use each equation? And there's two possible answers. There's law of cosines. That's going to tell us one thing. Law of sines is going to tell us a different thing. So I'm going to split this into two, right? I want to find a missing side length. So looking at law of cosines, I want to find A. I need to know B and C, which are side lengths, B and C. I need to know alpha, which is an angle. So for law of cosines, in order to solve for a missing side, I need two sides plus one angle. Yeah. B, C, and alpha. B, C, and alpha. B, C, and alpha. And we're going to do the same analysis on law of sines. So we're going to ignore the gamma. We're just going to look at these first two fractions and ask ourselves the same question. If I want to find that missing side length A, what do I need in order to do that? So if I'm solving for A, I need to know B, which is a side length. Yeah. I need to know alpha and beta, which are angles. The law of sines needs different things, right? I need one length and two angles. Which formula you use depends on which information you already have about the triangle. If you have two sides and an angle, you go cosines. If you have two angles and a side, you go sine. It'll be really obvious if you're using the wrong formula, because when you go to plug numbers into it, you won't have all of the ones you need. Yeah? If you are dealing with a triangle that is not a right triangle, these are the only two equations we have to choose from. So it's a quick process of elimination, yeah? You start with one. If you're missing pieces, try the other one. Yeah. What we're going to do today is we're going to do a couple examples of how to use this specifically, both in picture form and in number form. And then I'll give you time for your homework. Sound good? Yeah. Okay. So let's do some examples. I can draw the picture appropriately this time. Actually, I take that back. Ignore those. We don't care. What do I care about? This is 12. This is 10. That I care about. So first thing when we're solving a problem, what am I being asked to find? Looking at that picture, I see something labeled with a variable. I'm probably asked to find x, yeah? Which is a side length. I'm asked for a missing side length. And then I look at what I have. So what information am I given in that problem? 2 sides, 1 angle. And we remember from our previous discussion, 2 sides, 1 angle is cosine law. 2 angles, 1 side would be sine law. So to find x, I'm going to use the law of cosines. A squared, the side I'm looking for, is equal to b squared plus c squared, which are the other sides, minus 2 times b times c times cosine of the angle opposite the missing side. So I'm going to go through that picture and label the pieces as they're labeled in the formula. Yeah? We call our missing side A. So this is my A. Alpha should be opposite or across from A, so this must be alpha. The other 2 sides are B and C. Does the formula care which one I call B and which one I call C? I see a couple people shaking their head no. Good. Here, when I add the squares, adding is commutative. I can do it in any order. Here, they're being multiplied. I can multiply in any order. So it doesn't matter. I'm just going to label them top to bottom in the picture, B and C. If you did it backwards, you get the same answer. Yeah. So that part is the hard part of this problem. What do I want? What do I have? Which formula do I need? How do I match the pieces to the formula? Once we got that matching part done, it's plug the numbers into the formula, plug it in your calculator. Right? This is just the formulaic stuff. So a squared is being called x in this problem. B is 10. C is 12 minus 2 times 10 times 12 times cosine of, and alpha is 30 degrees. This is ready to be plugged in a calculator. Before we do that, should my calculator be in degrees or radians? Degrees, because the thing inside the cosine is in degrees. So check that your calculator says degree mode, and then plug that in your calculator, and check that we get the same answer. Because Mr. J has made several typos this morning, and I don't want to do it again. Oh yeah, see, there's another one. Okay, so I get 36.2 rounded to 1 decimal place. I see some nodding. Yay! Question: is that 36.2 my missing side length? Why no? Yes, very good. This is x squared, not x. I want x. How do I undo the square? Square root. Happy face. And I know 36 is a perfect square of 6, so x is going to be 6 point something. 36.2, 6.02, so about 6, yeah. Happy face? And that's it. That's it. For the plug and tug, make sure that your calculator is in the same mode as the angle measurement inside the cosine. Yeah. If they gave you units for the triangle lengths, inches, make sure those show up on your answer. Yeah. In terms of the scary stuff we've seen in trig this year, hopefully that's a little bit further down the list of scary. That one's not so bad. We're going to do a couple more. Yeah. So new triangle, two side lengths given, 3 and 16. Angle between them is 80. I want to know the side opposite that 80 degrees. Yeah. Asked for missing side. I have two sides in an angle. That's law of cosines. A squared equals b squared plus c squared minus 2bc cos alpha. You are going to get tired of writing that. If you want to know how I remember things so well, it's because I write it down every time I do a problem with it. That's what helps your memory. Write it down. Write it down. It'll be on your equation sheet for your final. But if you don't have to search for it as hard, that's helpful, yeah? You don't need to have it memorized, but it does speed things along. We're going to do the matching process. Which side is my A? X, good. That's the unknown side. Where is my angle? 80, this is my alpha. Omar, which one's my B, which one's my C? 16, did we have to do it in that order? No, very good. Yeah, not so scary. The side you want is A, the angle opposite is alpha, the other two are B and C. Yeah, plug them into the equation. X squared is 3 squared plus 16 squared minus 2 times 3 times 16 times cosine of 80 degrees. Happy face. And like the good college trig students that we are, we all brought our calculator. We grab our calculator. We plug it into our calculator. I see Sam plugging away on their calculator. Sam, what did you get? You haven't got it yet. Okay, I'll wait. It's big. You got a big number, that's okay. Oh no! Who has an answer on their calculator that hasn't been deleted? What did you get? 248.38. 333? So 33. I don't know why I heard an extra number in there. Thank you. Yeah. It's also what I got. That's good news. That makes us happy, yeah? what do I do next? Square root it, yeah. We're going to take a square root. And I'm going to do something kind of cheaty on my calculator because it's 2025. We have fancy calculators. I'm going to hit second square to pull up my square root. And then I'm going to go back and highlight not the answer from the previous line, but the expression, a squared plus b squared, or b squared plus c squared plus, you know, that whole thing. When you do that, you eliminate your rounding error. So if you do it the old way, which is square root of, what do we put on the board, 248.33, you get 15 point, and I'm going to copy this out further than we need to, 5, 8, 4, 8, 9, 7, 8. Yeah. If you do this the exact way, you get 15.7584823. Notice where the difference between those answers is happening. 1, 2, 3, 4, 5, 6th place past the decimal, right? This is where that first difference happens. Do we really have to worry about rounding error for these problems? Not unless you're launching something to the moon where precision matters. No. Yeah, if you're an engineer for NASA and you're trying to get someone to the moon with the minimum amount of fuel, then you care. Otherwise, no. Okay, hopefully that doesn't feel too bad. Do we think we can manage that? Okay, if you need to see more examples, give me a thumbs down. Otherwise, give me a thumbs up. Let me know where you're sitting. Where are we sitting? I see thumbs up. I see thumbs up and people who don't want to vote, which I'm assuming is a thumbs up. Okay. I'm going to stop my radio.